Would you like to say regarding this? Uh, do you have information? Little information about it. Exponent, which means, yeah, you are correct. Whatever you are thinking, I hope you will be right. You will be right. Exponent, which means this is the base. When we write like that, otherwise like that. So here we need to identify two things. First, base. Where is the base in this, and where is the exponent? So there are two things hidden in this digit. So always remember this down number will be known as base. What base? This upward number will be known as exponent. Okay. And whereas it is said that exponent will be said over power as well. Okay. So don't confuse. Exponent will be known as power as well. But base will be base. Base we can't define in another word. We can't we can't write it other word. Place of a base. Place of a exponent we can say what power. Power is also definition of this digit. So okay, you have to remember what downward would be known as a base and exponent whatever is written upward to the number of downward. So base. Now let's understand what is the meaning of this number. 3 raised to the power 2. So what is the meaning? It is saying this 2 exponent. Now you are clear? 2 is exponent. So exponent is the same dimension you can say. Now you have a 2 dimension. How many dimension? Di-dimensional you can say. Di-dimensional. Okay, di-dimension. 2 which means a di-dimensional. I am talking about the 2, not 3. 3 is our base. So we will write our base how many times? 2 times. So who is the same? Exponent is the same. Exponent is saying that you have a base. So base you will write 2 times. How much times? 2 times. 1, 2. 3 times 3. 3 times 3 will be as you know. Okay. This is our result. Okay. So we understood base, exponent, and it will be written 2 times. Then after multiply, we will get our in one digit. In digit. Clear? This is how we identify base, exponent, result, and this is how it is written. So first, I would like to take a step on the discussion of product rule. Product rule. So here, one thing more. Let's suppose, yeah, I am taking next. What? Let's say 4. 4 raised to the power 5. So it is saying that now you are clear. It can be written as 4. How many times? 5 times. 5 times. Now you will multiply it. Then you will get answer. Then and otherwise, similar here you can write what 4 is how many times? 5 times. 3 to 5. This is a way to write. Okay. Now we are moving to the product rule. Product rule, which means multiple rule. but it will be better to say product rule. Whereas if you are discussing it, so we can use a multiple rule. So it is saying that there is a one way. What? There is a one way to represent a product rule. What? Our base will be same. Our base will be same, but exponent will be opposite. Then we will be able to define our product rule. So we are going to break down this word. So it is the same. You have a base. Okay. You have base. This base and this base. Product rule we are taking. Okay. Product rule. So here, let's set 2 and 3. Clear? This hint, this operation is what of multiple. That's why we have a word which is a product, which is a product. So you can see our base. We have a base how much? 2, 3, 3. So here base is the same. This is a condition of our product rule word. This is a rule you can say. So base should be same. Then we can write it how? It says that base, if base is common, then we will write how many times? One times. Now we are in the context of a multiple. Then in the context of multiple, we see what? Addition. Addition. So exponent will be added. Exponents will be added. In this case, this is a way. If we have a base is the same, then exponents of a base will be added together. Okay. So can we write like that? Yeah. So does it make sense? Does it make sense? Yeah. You can write it like that. 3 how many times? 2 times. Okay. Then 3 times. Like that. Will be equal. So here we can see. We have how much? 3. We have how much? 3? 5. 1, 2, 3, 4, 5. So 3 we are adding. How much? 5. This and this we can see is equal. So it depends on us. If question gives us that you have this, otherwise you will have this. Question will decide. Otherwise, if you want to write this like that, whatever. Okay. So this is a way. If base is the same, then we can write 1 times, and exponents of multiple base will be written by adding. Okay. This is it. Okay. Did you understand? I am going to next, which is a division rule, and in other word we say the quotient rule. Quotient rule. Okay. Quotient rule. So it says quotient rule. What is the meaning of this word? So here quotient rule, as I was telling you, product word we can say instead of a product word we can say multiple rule. Similar here, instead of a quotient rule we can say division rule. So division rule is a simple word, whereas multiple is a simple word. So product word is formal word and quotient word is formal word. So our rule is, in this case, in this context, it is saying you have a division. You have a division. Let's say 5, then 2. We have a division like that. So where what is where is where all is what base? 5 is base, 3 is base, but 2 is exponent. 2 is not base, 6 is a base. First of all, identify where is base, where is exponent. Then our uh, what uh, understanding to identify base and exponent will be clear. So here condition is your base should be what same. Your our base should not be different. Then we can't write. We will not be able to use this rule. So here we have what mm, we have this and this. Base is the same. Can we write one time because we have a common. Now this is the first numerator, denominator, this is a denominator, and this is a numerator. So 2 as it. So here, in the case of a division, we see what subtraction, and in the case of multiple, we see what addition. Similarly, in the case of division, it will be opposite of addition. So subtract 6 as it. Now we have how much? Subtract 4. So can we write it how much? 4 times. 4 times. It will get cancelled out like that. Okay. Otherwise, here you can see uh, this is a how many times? 2 times, and this is how much? 6 times. This is a simple rule that we use. Instead of this, we can use this rule so that our time save. Okay, can save. How many times? 6 times. So here one will get cancelled and second will get cancelled. Now how much we have? Upward side is 1, upward 5 is 4 times. Can we write like that? Similar here, this is written. If we are writing denominator upward, then exponent will be opposite. If exponent is with addition, then we will write negative. If exponent is with subtraction, then in a denominator, our exponent will be with addition. So here, like that. So it makes a sense. This is a rule of this, and this is a proof that yeah, it can be written, and this is a proof that we can use this rule so that we can save our time. So to save our time, to instead of going long calculation, we use many rules. Okay, where we have a long calculating problems, then it is useful to use it. Okay. Clear? Clear. Next, just have a look for a few seconds. Now I am going to erase it. It's a time to power rule. We understood exponent rule and product rule, then quotient rule. Now it's a time to power rule. Power rule. Power rule. Meaning of this is it says that power rule. Power. How much? We have let's say six. Okay, six. Okay, yes, six. Six. And exponent is how much? Four. How much? Four. Now we have a power rule. What if our question, our problem is like that? Our problem is like that. Means we have two power. We have two power. One is 4 and second is third. We have two exponents. Like that we can say we have two exponents. First is 4, second is 3. So how can it be solved? Now this is the question. How can it be solved? This could be teeny complicated. Teeny complicated. So we solve it. Rule is because we are discussing about a rule. So first of all, this is a power rule because we have two rules. Otherwise, if we have three rules, then just have a rule. How can it be solved? Base will be acid because we have one base. Base will be acid. Okay. So here our exponent. Here we don't have like that 6 4 6 3. We don't have like this. We don't have like this. This and this, there are huge difference. Okay. Problem of this and problem. This is other question. This is other question. Got it? First of all, understand this. So here, meaning of this, it is saying that 6 raised to the power 4 is how much time? 3 times. Like that. Meaning of this is now whatever we know, then you can write like that. We are breaking down it. We are doing break down it. Then similar like that. Then similar this. Now you will add it, then you will get answer. You will get answer. So this is a way to write in short. This is a long. Yeah, you are getting confused to look it. So instead of writing like that, we can write like that way, in that way. This is a short, and this is a clarification. What is it saying? We can understand. So this is a way just. Otherwise, for more short, we can write like that. For more short, we can write like that. So first of all, we have a bigger. Then for short, our question we want to change our question. Question would be same. This is a long, so to short we write like that, and then more short we write like that. So meaning of this, and meaning of this, answer of this, and answer of this would be same. But just these are different to write in different way. Clear? So rule of this. It says if exponents is what exponents are we have exponents are 2 3, just multiply all the exponents. just multiply all the exponents whatever we have. Okay, whatever we have to multiply all the exponents together. So can we write it like that? Yeah. So how much we have? 12. So more clarification, we have 6 which raised to the power 12. So 6 will be written how many times? 12 times. So here you can see it makes a sense where 6 we have a base of 6. So how much time? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does it make sense? Yes. We have a proof as well as. Okay, we have a proof as well as. So this is a way to write in short. In short. Clear? So here like that we have a problem, then we can solve it by using power rule. Power rule says that just multiply all exponents whatever we have. But exponents should be with what? Like that. Okay, there. Did you understand? Did you understand? So you can write it like that. Just for remember, then multiply, then we will get answer. This is rule. Did you understand? Can we move to the next? Power of 0. Power of 0. So it is saying power, exponent is 0. Exponent is 0. Base is not 0. Base should not be 0. Okay. Let's say 6 like that. 10 raised to the power 0. What will be answer of this? Of this? Answer would be 1 1. Answer would be 1 1. Always remember but exponent is a 0 of base except 0. Except 0. What I'm saying, base should not be 0. If a base is a 0, then we can say infinite, otherwise. So except 0, we have a base whatever, and exponent is 0, then our answer would be 1 in each case. Okay. So when power is 0, exponent is 0, then our resultant would be 1. Okay. So answer would be 1 always. Answer would be 1. Just have a look. Just have a look. For more clarification, let's say we have what 6. Okay. Then we get what? We get, for more clarification, I would like to share with you for more clarification about power rule. Power of 0. Okay, power of 0. So here, just understand it very carefully. When we write like that, what is the meaning of this division? Base is the same. exponent is okay, as well same. So can we cut it? Yeah, then we will have how much? One. So whereas can it be written like that by using quotient rule? By using quotient rule, base is the same. Now exponent is 3 minus 3. We are using exponent because we have this type of question. Now it we have what, 0. So answer would 1. Just this is a way to different to write in different. Answer would be 1. So this is a proof. This is a proof. We used quotient rule. Our base is 5 and 3 minus 3 is becomes 0. Then we have 1. And when we have like that, then we get then it get cancel out. Then we get 1. Okay. Did you understand? Negative exponent. Negative exponents. Negative exponents. Exponent is negative. Is exponents is in negative. Mm, for example, 5. Then we have 6. Okay. So here this is exponent. Exponent is 6, but 6 is with the subtract operation. Subtract operation. Okay. So can we say, yeah, exponent is in negative? In this case, what would you do? What would you do? Is that uh, first of all, it can be written like that. 5 is in numerator. In a numerator. This is like that. Okay. So when we replace it, when we write numerator in denominator, then we write like that. Clear? Are you clear? Then our exponent, whatever is we have exponent with, if exponent is minus, then exponent will be changed. So opposite of subtraction is what, addition. Addition is hidden. Okay. So when we change our numerator, when we change our numerator number, then our exponent would be always change. What operation of end of exponent would be changed when we are changing numerator number there. So here we can see we are changing this numerator number, and we wrote in the place of, in place where denominator. Then similar here we have changed our sign of exponent, which was with minus with subtract. Then we have written only 6, which is hidden with addition. So this is the way many as answer of this and answer of this would be same. Clear? So how much? Let's say now you have like that. If you are writing like that, then our exponent would be uh, minus 7, because here is with addition. Okay. In this case, we have this problem. We wanted to change it, then we can write like that. Okay. In our question, like that, problems, short problem will come. This type of is said what a negative exponent. Now, what do you think about fractional exponents? Fractional exponent. Fractional exponents. So we saw this problem. Now exponent would be in a fraction. Do you know? Like that means in division. Something number is upon something like that. This is a fraction. Now our exponent is a fraction. Our exponent is a fraction. Then, so fractional exponents. So let's say base is a 7 and exponent is 1 by 2. So 1 by 2 is also defined as a root, a radical. So we can write it like that. Okay. Meaning of root is what? 1 by 2. Okay. Now, exponent is minus 3 by 2. Then minus 3 by 2. So here, just to look what is a way to write in another way. 7 would be as it. Here, can we write it 1 by 2? When we are writing 1 by 2, then we have what? Only minus 3. Am I right? This is a way. Okay. Now 1 by 2 is known as root. Now we have minus 3 by 2. This is a way just. This is a way. It's a way to write. Okay. To write it. Seven 1 by 3. So here this 3 is a saying that this 3 and this 2. 2 is a hidden root in a root case. Now 3 is the same. This side you will write 3, and now you have 7. Okay. This denominator number will be written here. Clear? 7 will be as it. Now 1 by 2 we use it as root. Let's say we have a 6 by 3. Then we have what? Can we write it like that? 6 multiple 1 by 3. Now we have 7 and 1 by 3. 3 will be written here. So denominator word will be written here, and now we have 6, which is exponent. Clear? So numerator would be exponent in the case of fractional exponents. Denominator will be written as this side. Clear, brother? Let's say you have 7 by 10. Now can we write it 1 by 10 multiple 7? Then 10 is saying this side would be 10 and this as it is, and now whatever we have x7, 7 is exponent. 7 is exponent. It's a way just. You can write it like that, you can write it like that, you can write it like that. Okay. How to identify where should we use fractional exponents? Where should we use product rule and constant rule, quotient rule? Now, did you understand about it? It is saying this is a base and base is a 7 times. This base is a 6 times. This base is in a negative 3 times. Till here already you know. Next, which is a different something. Distributor and exponent over a product. So meaning of this sentence, just understand what is it saying this word. Distribute means a distribution, dividing, distribution. Multiply which means collection, distribution which means dividing. 1 is here, 2 is here, 3 is here, like that. Distribution and exponent over a product. We would have a product, but over a product is exponent. So we will divide our exponent in other place. Did you understand something? Means the question is x and y. This is a 2 base. Now we have n. N is exponent. N is exponent. N is exponent. Just try to understand. X is base, y is base as well. But n is exponent, n is exponent. So it is saying you have a product. Base is with the product. Base is with the multiplication. That's why we will be able to use this by saying this statement. But what if we have what plus addition instead of multiplication? Then we will not use, we will not be able, we will not be depend on this statement. Clear? So it is saying multiply. So it can be written as like that. Why? We did distribute it. That's it. Okay, and meaning of this and meaning of this is the same. Now we have a what exponent is a common. Exponent is a common, but base is a what different. Base is a different. So exponent will be common, and we will distribute our base. Just that's it. Let's just say we have like that, and now we have to. Okay, so it is the same. This is in brackets, so we can write that 5 with the 2 exponent, whereas 6 with the 2 exponent, because 2 is a part of this 2 base. That's why. Otherwise this is like that, then we cannot write it 5 to 6 to. No, this is a correct. Here who is giving permission to use this exponent with this exponent in this bracket is giving addition permission. Okay, this would be wrong. Now this 2 base is in exponent with one bracket with one exponent. That's why we can write it like that. It is saying this exponent is with this base as well, and this exponent is with this base. Clear? Does it make sense? Does it make sense? And does it make sense? So let's see. So it is saying 5 times 6 is 2 times. How much time? 2 times. Similar here. 5 is 2 times. And 6 is 2 times. We can see 5, 5, and then 6, 6. 5, 5, and 6, 6. LHS and RHS is equal. So we can, hence it is proved that we can write this, and whereas if we want to write like that, then we can write. So value of this and value of this would be equal. Okay, this is a way to write. So here we did distribute our exponent with the base with the base. Clear? So condition is there should be product there. If in the case of addition and subtraction, there will be impossible. Now we have what? Quotient. Quotient. Did you understand? I did write quotient. What is the meaning of this statement? Now, this statement is saying We have a quotient. We have a quotient with exponents. So let's see 6 and 8 with exponent. How much? 3. This is just example. Let's say we have this problem. Now, how would we solve it? So it is the same. Bracket is giving permission us to write base with this exponent and this base with this exponent. Whereas this is like that. Then we cannot write it like that. No, because this exponent is with this, not with this. Okay, and this exponent is with this, and this exponent is with it, because bracket. Clear? This would be wrong. So here it is saying 6 is with 3 exponent, 6 is with 3 exponent, and whereas it is with 3 exponent. Clear? I said we can write like that because bracket is the same. 6 is with 3 exponent, whereas 8 is with 3 exponent as well. Does it make sense? Do you want to see proof a proof? 6 by 8 is how much? 3 times. Whereas 6 is how much? 3 times. 1 second. And 8 is with 3 times. Clear? Can we write it like that? No. LHS is equals to RHS. So it is saying that yeah, this this can be written as like this, and this can be written as like that. Okay, because LHS and RHS is the same. Clear? So remember bracket remember. Just have a look for a few seconds. Now, I wanted to say you in the case of addition and subtraction, we want to use this type of method. We want to use this type of method in the case of addition and in the case of subtraction. Okay, clear? Now, whatever we have studied, we saw. I am going to write together. Just a recap. We saw first the product rule, then the quotient rule, then the power rule, then power of 0, then negative exponent, exponents, then fractional exponents, then we had distribute and exponent over a product, then we had distribute and exponent over a product. Just a recap. So in the case of the product rule, whenever we are going to use product rule, then we are thinking that it means we have what base like that. Okay, and exponent is a different, and exponent would be same like that. We have this. Then in this case, the product rule says that exponent will be added because of, in the case of a product rule, and we have what base which is a common, that's why we wrote what one time. Now we have what 6 10 times, clear? Whereas we can write like that, it can be written a is a common and exponent will be added. We saw this in the discussion of the product rule. Now in the discussion of the quotient rule, what does it say? It says that now we came in the division field. First of all, base is the same, and now we have exponent. Base is the same, that's why we will write what one time. Now our exponent, in the case of the quotient rule, exponent will be subtracted. Exponents will be subtracted in the case of the quotient rule. And as we know, whenever we see division, then we see subtraction. Clear? So exponent will be added. And whereas we know that this 6 upon 6 raised to the power 7 is 1 by 6. So here we are changing denominator into numerator. So can we write it 6 raised to the power minus 7? Yeah. Now we have this. And it can be written as a minus like that. Yeah. The power it says 6, then power no 6 is with 3 exponent, then we have 7. This is a problem. Okay, now in the case of power rule, whatever we have exponents, we will just multiply all the exponents together. So here you can see what I am doing. 7 3 times 21, and now we have what in simple digit 6 raised to the power 21. So here can we write in alphabet what A, and now A, then N. So here whatever we have exponents, we will multiply just. We will get answer. Clear? Now in the case of a power zero, it says base raised to the power 0, then 7, that's the same. We have what is 0? 0. Then in each case would be 1. Similar here. Okay. There would be 1. Okay. So base is anything. Base is anything. And base is raised to the power 0, then would be 1. Result would be 1. Clear? Negative exponents. So here we have like that. So it can be written A and would be 1. Okay, clear? So here 7 is a base with a negative exponent. It will be written like that. We are changing number which is in numerator L to denominator. So then our hint will be changed automatically, which like that. So we can write it A, and then we will write. Clear? Now it's a time to fractional exponents. Fractional exponents. Fractional exponents. It is saying we have exponent, but exponent is in fractional. Exponent is a fraction. Let's say 6. Okay. Then we have 2 by 3, like that. So it can be written like that. 2 is a numerator, then 1 by 3, and then 6. So here 1 by 3 is root cube, you can say. Okay. This side will be written what number which is the denominator. Okay, and numerator will be what will be exponent. Clear, brother? 6 will be written in under root. Then we have 2 exponent. Clear? So in this case, like that. So what are you understanding? You are understanding that numerator will be written here and denominator will be exponent. Clear? Now we have two last. First, distribute an exponent over a product. We have a product, which is base, and we are going to distribute an exponent of base. Yeah. Base is different like that, but exponent is common of 6. So bracket is compulsory in this two case. Bracket is compulsory. Bracket is giving us permission. So it is saying this 3 base is with the 6 exponent, whereas 7 base is with the 6 exponent as well. So can we write it 7 like that? Yeah. So now this is A, this B, and this N. So in the case of a product and in the case of What? Quotient. Okay. So a multiple b, then raised to the power 6. This is a number. Then it will be written like that. Clear. Now it's time to this. It is saying that we have a question 7 by 8. Let's say 7 by 8 like that. Otherwise, we can write 9. Now bracket is the same. Your 7, which is a base, is with 9 exponent. 9 exponent. Whereas 8 is a base. So 8 is a base. It doesn't matter denominator or numerator. So our 8, which is a base, is with 9 exponent as well. This is the rule. So a by b, then a. It can be written as a raised to the power n and then b raised to the power n. All this we saw with some question, with some rule, and we did try to understand it. We did try to understand it. Just have a look. Then I will jump on the next question. Just have a look. We understood it. Now we have some question regarding this with expression, with algebraic expression. Now let's see, can we solve our algebraic expression with this rule? Okay, with this rule. Are you ready? Are you ready? This was rule a expression. We have a question with algebraic expression. In algebraic expression, a 3x square in negative and then b 4 y cube and y minus. How would you solve it? How would you solve it? Do you have any idea to solve it? Yeah, most of you, most of you would have some idea to solve it. So, in this equation, we will notice that yeah, some rule that we saw that we studied is coming here to apply here. Okay, to apply in this question. Now we have a question to simplify. So three is with a product. Okay, is with product. Now we have like that. So here, try to notice. This is what our base is the same, and this is a division. So quotient rule, and now now can we what reduce? Can we subtract our exponents by using quotient rule? By using quotient rule? Yeah, of course. So let's see, 3 as it, and x is a common, and minus 2, and as you know this x4 is 1 by x4, so it is written x minus 4. So we know that base is same. Now we can solve it. Would be how much? 6, like that. Clear? This is a one way, and second way. Okay. So by using quotient rule, we applied quotient rule, and then we did simplify it. Now other way, 3, and this is our exponent with base is what in negative. So 3. So can we write it like that? Of course. And x4, can we write it like that? Of course. Yeah, am I right? We didn't change in our question. Now, as it, when we change our division into multiply, then our this denominator or x denominator variable change their position. How? X raised to the power minus 4 would be in numerator. Would be in numerator. Am I correct? Like that. Okay. We didn't apply any rule. Any rule. Any rule. Now we can solve like that. X is how much time? 4 time, isn't it? And downward, how much time? 2 time. So 1 will get cancelled out. So here 1 and 1x. Now what we have? We have 3x, and then and 1 will get cancelled out. How much? 3x square. 3x square. So So exponents should not be in negative. Then we can write it like that. Uh, so here what we have how much? Now we have 2. Is it correct? Now it's correct. It's correct. Okay. I did something wrong. Now it's correct. So here just we factor our exponents. Clear? Now other way. Okay. So this is one way, and this is the second way, and third way. Third way. So third way would be 3x square. Okay. Yeah, that's the same. And like that. Okay. So we can change it. Then would be like that. Then it would be like that. Now, uh, to use product rule, then we can we write it x minus 2, and then it will be as it. Now we have what base is the same. We can apply our product rule. Minus 2, then minus 4. Okay, would be how much? Would be how much? Minus 6. But wait, hold on. Answer is different. Answer is different. So here, yeah, this was correct. This was correct. Now here, now here. X6, then X6, 4 times, 2 times. Now we have 2. This is not way. So here in this way we applied what quotient rule. Quotient rule. Where is the quotient rule? This. And here we applied our product rule. Okay, product rule. Now it's a time to this question. It's time to this question. So here 4 similar 1 by 4, 1 by y minus 3, and then y 1 by y. Okay. Then 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would change their position. 4 as it. Now this denominator would chan So can we write this? Okay, now we have what? 4 as it. Can we write it to apply? Otherwise, we can apply what? Exponent, exponent, quotient. How? Here, y 5 y 3. Then our would be what? Y 5 and then plus 3. Okay, this is the first. And second, by using product rule. 4 then y 3, we removed fraction. Then now we have as it 1 is added. Now we have a what? Product rule. Y is common, 3 plus 5. Can we write it? 4 what? This and this you can see is the same. So here we applied two rules. First here constant rule and here product rule. So whatever you want to use, that you can use. Answer will be same. If you are looking, if you are getting notice that yeah here I can apply this rule, then you can reply. Then see your answer. Just have a look. Yeah, next. Next we have expression, algebraic expression. Y 3 then Z 5. Now we have this expression which is algebraic expression. Okay, which is algebraic expression. So y3 and y4 we are doing. So here we are getting notice that we can apply quotient rule. How? So y3 and here y7 and y is common 7, like that we applied quotient rule. Then z5, then here z minus 2. So would be what? Add, clear, and then upon 7 will be there. Then just minus 4 and then z which is with 7 exponent 7. This is answer. Otherwise we can use what product rule. This was a way by applying quotient rule. Okay. So here y. So can we write y3? No. 1 by We are going to apply product rule. This was quotient product. So y3 and z5. So here 1 by y7. So can we write y7? We just changed our position of y7 into denominator, and then we have z5, and then in denominator we have z with a negative 2 exponent. So in numerator we will write it how, like that. Am I right? Yeah. And 7 will be upon. Now we have what? Product rule. Then as we know, exponents is added together. Okay, z 5, and here we are looking -2, then plus, so minus, and minus, here is 5 already, and then 2, minus minus happens 2. How much? 3 upon 7. So y is with 10, y is with 10. So 3, and this is a minus, then it would be 10. Clear? Upon 7. I think so. This is wrong. I did something wrong. You solve it, and then what happens? Then see what happens. I would like to take next question. As of now, that's it. You will solve it. You will solve it, then see your answer.